All right, let's review the why of a hypothesis test. We've kind of already talked about this.
You want us to write that down?
Yes. You write whatever you want to write. It's just up there for you guys. So you can write as much or as little as you like because these are your notes.
Well, I don't know how much I can write.
Yes.
You're a Speedy Gonzalez.
So, hypothesis testing. This is the kind of the formal definition, which could show up like on a multiple choice question. So I would say that you need to memorize this definition. That basically is kind of my interpretation of it so that you can understand what it is.
Oh, really?
So basically what a hypothesis test is there is a claim. So the example that we gave was 5% of TV remotes are found in the freezer or the refrigerator. But the researcher, the person that creates this wondering or this hypothesis thinks that that number is either too high or too low or just plain wrong. So they go out and they take a sample and they compare that sample to the 5%, to the population or to the null hypothesis. Then we're going to run this hypothesis test. So we're going to do some calculations to decide can we or do we have enough evidence to prove that 5% wrong or not?
Yes.
So if we reject, that means we do have enough evidence. If we fail to reject, that means we don't have enough evidence. Let's review what a proportion is versus like what a mean is. So we've got proportions and we have means. A proportion refers to a fraction or like a percentage or something. So 2 out of 4, 50%, something like that. You don't need to write all of the for example if you don't want to. If you want to just write what a proportion is, then that's fine. Because it'll get to the point, and we kind of did this last chapter, it gets to the point where they're all jumbled together, where you've got proportions, then you've got means with T, and you've got means with Z, and there's 3 of them, and how do you decide which is which? So we're going to try and do a better job at preparing for that this time.
Yes, that was easy though.
Okay, first step. Did you write the whole example?
I did.
Certain attribute, no.
Okay, certain attribute. Okay, step 1. So we're going to learn how to do like a full write-up. This would be your free response, where you're just running the hypothesis test from start to finish. And you guys have learned bits and pieces of it. So we've learned this step, but this is your step number 1, writing the hypotheses. So your null is always equal to. Null hypothesis is always equal. Your alternative is either less than, greater than, not equal to. You don't have to if you don't. You write whatever you want.
Wait, but I don't.
Cheese be ruthless.
That's just saying that it has to equal.
These are the same hypotheses that we learned in like 8.1a. So it's either like P equals,
Oh, okay.
yeah. This P sub 0 is just like, it's always going to be a number. Whatever number that they give you, that's the claim. That's not how you spell claim. And then your alternative is either not equal to, less than, or greater than. Knowing that not equal to is two-tailed and that these are one-tailed is important.
How do you, whenever it doesn't say in the problem which direction the test is, how do you tell?
By the verbiage, like if it says more than, then it's a right tail. If it says less than, if it has the word different, then that is going to be not equal to.
Isn't it number 2 is a left tail and number 3 is a right?
Yeah.
Okay,
So you could even put left and right.
okay, isn't that how you do memorize it?
Uh-huh.
Is Miss Lindsay Arnold's here today?
Nope. Step 2 is the conditions. And these are the same conditions from the last chapter. So random sample and proving n times p and n times 1 minus p are greater than or equal to 5. And that proves that we have a normal distribution.
Hold on, see. You're going to come a little fast.
I will. Give you
I
some
had
time.
dyslexia.
The test statistic, which we already talked about what that is last section, but now we're gonna learn how to calculate it. So this formula is on the formula chart.
I love formula chart.
Yes, you do need to know what a test statistic is. It's on like 8.1a or something, maybe, or 8.1b, one of those. So you already have this formula, but if you want to write it down again, it wouldn't hurt. It's just your z-score. Yeah. Just your z-score comparing the difference between your sample and your null proportion. This formula is on the formula chart. But if you want to reference it right now and have it, I would write it down. Because I don't have the formula chart printed for you guys right now. So this Z right here is called the test statistic. So far, you've only just been given the test statistic, but we haven't actually solved for it yet. Step 4 is the p-value. So you go from test statistic to p-value, which we have already done. What do we do in the calculator to find that? Normal CDF. So this is the definition of p-value. I'm going to tell you right now that this equation will most likely, or not this equation, this definition will be on your dual credit test, like 100%. So do memorize that.
You have to like write it.
And it was on your quiz too, your last quiz. Not that you have to write it out, but just that you need to be able to recognize it.
Like our test at the end of the year thing.
Yeah.
I want to borrow it.
Yeah, I actually studied all of this.
I missed this one.
Why was that?
Mm.
I thought it was
I
false.
already brought some for Spanish and I sat there with 2 forms.
Yeah, we just done.
So if you have a less than test,
I'm in Mason.
then you're going to do normal CDF of negative infinity to whatever your test statistic is. So go to negative infinity. If you have a greater than test, you go to positive infinity. And if you know all this, you don't need to write it down. And then if you have a two-tail test, it's always 2 times your area.
But what side do you take it from?
It depends on like if you have a positive. So if they give you, if you're given a positive z, then you're going to go to positive infinity and multiply it. But if you're given a negative 1, you're going to do negative infinity. So you go like to the outside, whatever you're given, and then multiply it. Don't ever cross the center. Don't ever cross the center.
What does that mean, Miss Ormill? You're telling us not to live our lives?
Sure.
Sure.
Wait, what happened? What happened?
Okay, next step is you make a decision. So you compare your p-value to alpha. If the p-value is less than alpha, you reject. If it's greater than, then you fail to reject.
Me too.
I'm glad you like it.
This or right here is talking about the rejection region, which we're going to do last today. I talked a little bit about it, what the rejection region was, which we'll get into at the end of this lesson. So just put inside, in rejection region, reject, outside rejection region, fail to reject. That's all I would write.
What?
And you'll understand what that means in a minute.
Inside is in, outside. What? What rejection is it? What do I need to write?
What it says?
Is in, reject, outside, fails to reject. Okay. Is in, reject.
Test statistic out of rejection region, you fail to reject.
Test. That's my last step.
The last step, well, 7 is like an optional step.
Okay.
Step 6 is the conclusion in context. So that is where you say there is or there is not sufficient evidence to conclude. So step 5 and 6 are kind of, I usually combine them into one because that's our final conclusion. This is literally combining everything we've learned.
Are we learning anything new today?
No.
Perfect.
I wouldn't say so. The rejection region might be a little bit new.
Power to like come into this too.
Yes.
Okay, so yes.
Everything is connected.
All right, Gene, I'm gonna go to the bathroom. All right,
Come back here. Are we doing something fun tomorrow?
yeah, who cares?
These are the traditional steps, like using the p-value, comparing it to alpha, then making your decision. Sometimes they will ask you, this is like a separate way to do it, and you need to know how, but traditionally we don't ever use this way. So they may ask you questions about this other option, this rejection region approach. So you need to know how to do it, but in a formal write-up, we don't ever use it. So they would just ask you a follow-up question about it. And I have this all written down for you so that you don't have to write it all. But what the rejection region is basically it's not calculating the p-value at all. It's just using your test statistic and comparing if it's inside or outside the rejection region. And you find that by looking at the normal curve and writing in or finding what the critical value is. Guys, stop. The critical value is always based on your alpha. So I think on your My Math Lab, you actually had to calculate the critical value, but we're going to do that more today.
Wait, it was like the point inverse normal.
Yes.
0.01?
Yes. So that is, the critical value is like your boundary for your rejection region or not. And so the best way to explain it is by doing some examples. So let's say that I'm given a 5% significance level. I'm doing a right tail test, and this is the Z that I get. So I've got this normal curve. A right tail test means that it's at the top, right here. My rejection region, if I have 5% significance level, would mean that this shaded area needs to be 5%. So what percentile is that at?
95.
The 95th percentile. So I need to figure out what that is in my calculator. What is the 95th percentile? So I would do inverse norm of 0.95, 0, and 1. And so somebody do that really quickly and tell me what you get. I think it's like 1.96 maybe, but I'm not sure. 1.645 maybe.
Yeah.
1.645. Okay, so this boundary right here is 1.645. But my Z is over here. Is it inside the rejection region or not?
No.
No.
Like, is it in the shaded area?
Oh yes. It would
Yeah,
be, yes.
it is, because it's to the right of 1.645. So since it's in the rejection region, then I'm going to reject
We reject.
the hoe. Okay?
So we would just get a question that literally looks like that.
Yeah.
Okay.
So I want you to try the left tail test, and then we're going to come back and do the two tail test.
Oh, I was about to say two tails.
I'll show you how to do the two tail one. So I want y'all to do the left tail test one. If it's a left tail test, and this is 1%, 0.01.
Point zero zero
Wait,
zero five.
so for our left tail, do you just use the
You just-
significance level, but for the right tail,
You do 1 minus it. So if it's a right tail, it's 1 minus the significance level. If it's a left tail, it's just the significance level.
Negative 2.326.
Negative 2 point what?
326.
6. And negative 1.234 is like over here. So I would fail to reject.
I like these. This makes sense. I'm saying.
For a two-tail test, what it is doing is it's taking your significance level and it's splitting it in half. So if I have a 10% significance level, I have 5% over here, and I have 5% over here.
Oh, so we have to do it like that, so it's like.
So I need two numbers. I need the 5th percentile and the 95th. We already know that the 95th is what? Because we just did it. 1.645. Just so happens that the 5th percentile is negative 1.645. So they're always negative. They're opposite signs of each other. But my Z is at negative 2.14. So I've got two rejection regions now. Upper and lower. It doesn't matter which one it's in, but if it's in one of them, then I reject. And so negative 2.14 is here. So I would reject.
Can I ask a question?
Yes.
Did you just take that 10% significance level and split it between the two sides?
Uh-huh.
5 and 5.
Yeah, 5 and 5.
I'm confused too.
So we're going to take an example. We're going to go through all the steps. Oh, the next page is just helpful notes. I didn't put them on the PowerPoint, but they're just like little tips. Like one of them says never accept the hoe, something like that. So just little things to look over before a test.
Little things, except for the aircraft.
Yep. Okay, so here we have, so it says there are two major college entrance exams that a majority of colleges accept, the SAT and ACT. ACT looked at historical records and established 22 as the minimum score on ACT math for a student to be considered prepared for college. So basically, if you made a 22 or above on math, then you're prepared for college. That's what they decided.
Yikes.
An official with an Illinois State Department of Education wonders whether less than half of the students in her state are prepared for college algebra. So basically, the state of Illinois thinks that their students are not prepared. So she obtains a random sample of 500 students and records their ACT and finds that 219 are prepared. So that means 219 of them scored at least 22 on the ACT. Does this represent evidence that less than half of the students in the state of Illinois are prepared for math upon graduation from high school? So she's trying to see if less than half of them are. So my hypotheses, that's my step 1, is hypotheses. So my null hypothesis would be what? P equals 0.5, and I'm trying to prove less than. So P is less than 0.5, where P represents what? True proportion of students in the state of Illinois prepared for college math upon graduation. My step 2, I'm going to check my assumptions. So the first assumption is what?
Random.
So random sample of 500 students. Says it in the problem. And then the second thing I check is n times p and n times 1 minus p. And this is where I'm looking at the population number. So my sample is 500, but what is my p? Like, what is my null? 0.5. So I'm using my null hypothesis number. I'm using my null hypothesis number, so that is 250. 500 times 0.5 is also 250. They're both greater than or equal to 5. So the sample is large enough for a normal distribution.
Do we have to
Yeah.
write that whole thing? The sample is large enough for normal distribution?
Yeah, as long as you have the words normal distribution on there, then you're okay. So we've got z equals p hat minus p over square root p 1 minus p over n. So let's talk about all the things that we need. We need p hat, which in the problem it's my sample. So how many of them are prepared for college? 219 out of
That's 44%.
500.
Or 43.8.
So 0.44.
Yeah.
So let's just use the 2 decimal places. If you want to keep it in the fraction, you can if you want to be more exact. So we've got 0.44 minus 0.5 divided by square root 0.5, 0.5 over 500. What do you get?
Wait, question. Where the 0.5 come from?
Those are my proportions from the null hypothesis.
Alright. What's that equal to?
What does it equal?
Negative 2.6832.
Negative 2.68 what?
32.
So I'm going to say negative 2.6833. I'm going to go out 4 decimal places. From here, how do I find the p-value from here? Normal CDF. So step 4, is it step 4?
Yeah.
Is that wrong? So step 4, I'm going to find the p-value. So normal CDF, negative 2.6833? Actually, I don't want to do that one first. I want to do negative infinity first because it's a left tail test. And
Because of the sign.
Tell him, Squad Dog.
0.003645.
0.003645.
I can figure out that.
Perfect.
Oh, okay.
Yeah, so I don't know why
You wrote that.
I told you I don't know my grade.
And what's my alpha? I'm just going to write it out to the side. My alpha is what? 0.05. I'm just going to write it right here so that I have it there to compare it.
Wait, how do you know where you
It's in our next.
Oh, okay.
Automatically.
You don't have it.
So, next step is I'm going to make my decision. So I'm going to say, since the p-value,
Do we write that in 5 or 6?
5. So since the p-value is less than alpha, I do what? Reject HO. That's your step 5. Yeah. Something along the lines of P being less than alpha, I reject HO. That's step 5.
Not H-O, it's Ho.
The 6 where we talk about.
So then number 6, since I reject, what's the second part of that phrase? There is sufficient evidence to suggest what? What's my alternative?
That there's not enough students, less than half,
That less
prepared for math,
than half
college math.
of Illinois students are prepared for college math. Okay, step 7 is where they'll ask you about the rejection region, and this is just another way to prove that this test statistic should be in your rejection region. So going off the examples, we've got a what tail test, left or right? Left. And it's a 5% significance level. So let's draw our little normal curve. And what percentile am I looking for? Inverse norm of 0.05.
Wait, where did we? Oh.
Isn't that -1.6?
Negative 1.645. And what was my test statistic again?
-2.6833.
Negative 2.6833. Was that in my rejection region? Yes. So it's in rejection region. So I reject.
I just